Imagine being trapped in a damaged spacecraft 200,000 miles from Earth, with your oxygen leaking away. No rescue ship was coming. Your only way home was a machine never designed to keep you alive. On April 11, 1970, Apollo 13 lifted off from Kennedy Space Center in Florida. The crew was Commander Jim Lovell, Command Module Pilot Jack Swigert, and Lunar Module Pilot Fred Hayes. Their mission was supposed to be the third crewed landing on the moon. For the first 2 days, the flight looked almost routine. That was part of the danger. By 1970, the world had already watched Apollo 11 land on the moon. Apollo 12 had followed successfully. Public attention was fading. Even the television networks did not carry the crew's live broadcast from space. Inside the spacecraft, however, nothing felt ordinary. Apollo 13 was traveling faster than a rifle bullet. It was crossing a silent ocean with no harbor, no tow rope, and no second chance. The astronauts lived inside the command module, named Odyssey. Attached to it was the lunar module, Aquarius. Aquarius was built to carry 2 men from lunar orbit to the moon's surface. It was not built as a lifeboat, but history was about to change its job. On the evening of April 13, the crew was about 56 hours into the mission. They had just finished a television broadcast. Mission Control in Houston asked Jack Swigert to perform a routine task. He was told to stir the oxygen tanks. This mixed the super cold oxygen inside the service module. Swigert flipped the switches. Seconds later, the spacecraft shook. The astronauts heard a loud bang. Warning lights flashed across the control panel. At first, nobody knew what had happened. Then Swigert radioed the words, now known around the world. Okay, Houston, we've had a problem here. Jim Lovell looked out the spacecraft window. He saw something venting into space. It looked like a cloud pouring from the side of the ship. That cloud was oxygen. It was not just breathing gas. It also fed the fuel cells that produced electricity and water. One oxygen tank had exploded. The second was losing pressure. The command module was dying. In Houston, flight controllers watched their screens turn into a nightmare. Readings made no sense at first. Some thought the instruments were wrong. Then the truth became clear. Apollo 13 could not land on the moon. The mission had become survival. Flight director Gene Kranz and his team made the decision quickly. The crew had to shut down Odyssey to save its batteries. Then they had to move into Aquarius. The lunar module became their lifeboat. But Aquarius had a serious problem. It was designed for 2 astronauts for about 2 days. Now it had to keep 3 astronauts alive for nearly 4 days. The crew crawled through the tunnel between the 2 spacecraft. They powered up Aquarius while Odyssey faded into cold darkness. It was like moving from a ship's bridge into a small emergency raft. Every amp of electricity mattered. Every drop of water mattered. Every breath changed the math. The moon was still ahead of them. They could not simply turn around and drive back. Spacecraft do not move like cars on a road. They needed the moon's gravity to swing them back toward Earth. That meant flying farther away before coming home. On April 15, Apollo 13 passed behind the moon. For a time, radio contact with Earth was lost. The astronauts were more than 248,000 miles from home. No humans had ever been farther from Earth. They could see the lunar surface below them. It was the world they were supposed to walk on. Lovell had trained for years to land there. Hayes was supposed to become one of the next men on the moon. Instead, they could only look. The moon was no longer a destination. It was a bend in the road home. As Apollo 13 swung around the moon, another danger grew inside the cabin. The astronauts were exhaling carbon dioxide. The lunar module's round filters were not enough for 3 men. The command module had extra filters, but they were square. The lunar module sockets were round. The crew had square cartridges. The ship needed round holes. In Houston, engineers dumped materials onto a table. They used only items available inside the spacecraft. Plastic bags, cardboard, tape, and a flight manual cover became survival equipment. The solution was strange, ugly, and absolutely real. Mission Control radioed instructions to the crew. The astronauts built the adapter by hand in space. It worked. Carbon dioxide levels fell. One crisis had been beaten with tape, paper, and calm voices. But the spacecraft was still freezing. To save power, most systems stayed off. Water condensed on the walls. The astronauts slept badly if at all. Fred Hayes developed a urinary tract infection and fever. They were dehydrated because water had to be rationed. Their food became hard to eat. Their hands were cold. Their minds had to stay sharp anyway. The course back to Earth was not perfect. Small engine burns were required, but the usual navigation systems were limited. The crew used the Sun and Earth as references. At one point, they had to control the spacecraft manually. Lovell, Swigert, and Hayes fired the lunar module engine. They watched Earth through the window. They kept the planet in the right position by hand. Too much thrust, and they could miss Earth. Too little, and they could enter too shallow. A shallow entry could make them skip off the atmosphere. A steep entry could destroy them in heat and force. There was no margin for panic. Mission control worked in shifts without rest. Engineers calculated procedures never practiced exactly this way. They had to bring a dead command module back to life. They had to do it with limited battery power. The re-entry checklist was rewritten under pressure. Every switch had to be timed. Every system had to wake in the right order. The crew also had to separate the damaged service module. When they did, they finally saw the wound. One whole panel had been blown away. The damage was massive. Lovell later said there was an entire side missing. The explosion had crippled the spacecraft, yet the thin heat shield behind the command module appeared intact. That mattered more than anything. Only Odyssey could survive re-entry through Earth's atmosphere. Aquarius had saved them in space, but Aquarius could not bring them through fire. Before re-entry, the crew had to leave their lifeboat behind. They moved back into the cold command module. They powered systems carefully. They prepared to jettison Aquarius. Lovell later called the lunar module a good ship. It had been built to land on the moon. Instead, it carried 3 men home. On April 17, 1970, Apollo 13 approached Earth. The crew separated from Aquarius. The lunar module burned up in the atmosphere as planned. Odyssey entered the upper atmosphere at enormous speed. Outside, the heat shield faced temperatures of thousands of degrees. Radio contact always disappeared during re-entry. Ionized gas blocked the signal. For Apollo 13, the blackout lasted longer than expected. In mission control, nobody moved much. Families waited. The world listened. Then the signal returned. Apollo 13 was alive. Parachutes opened above the Pacific Ocean. The command module splashed down safely near Samoa. Recovery forces from the aircraft carrier USS Iwo Jima reached the crew. Lovell, Swigert, and Hayes were exhausted, but all 3 were alive. Apollo 13 never landed on the moon. It did something harder to explain. It showed how training, engineering, and discipline can defeat disaster. The accident was later traced to oxygen tank number 2. The tank had been damaged before flight. A combination of design history, handling, and electrical problems led to catastrophe. After Apollo 13, NASA made major changes. Future spacecraft carried more emergency supplies. Oxygen systems were redesigned. Procedures were reviewed in detail. The phrase "successful failure" became attached to the mission. It failed to reach the moon. It succeeded in bringing its crew home. That success was not luck alone. It came from thousands of people doing exact work under impossible pressure. It came from astronauts who followed procedures while freezing and exhausted. It came from engineers who solved problems using what was already on board. There was no mysterious signal, no vanished crew, no final door at the end of a haunted corridor. There was only a real spacecraft, real damage, and real people facing death. And if you ask what the final door was, history gives a simple answer. It was the hatch back into Odyssey, cold, dark, and uncertain. The astronauts opened it because there was no other way home.